Good morning and a very warm welcome to today's webinar, Next Generation Fraud Solutions, built on Neo4j, where I would like to show you some possibilities how to take advantage of graphs building fraud solutions. For the agenda, I would like to start with some general remarks how Neo4j fits building your next generation solutions. Then I would like to get a bit more specific on the advantages for fraud solutions by first describing the challenge, then talking about how you can benefit from graph technology, which brings us then to a brief description how you can build a graph-based solutions. And we will end with some conclusions how you can turn this into your advantage. Looking at the applications available in the IT industries, one of the questions I have is, with all the changes in technology over the past decades, new abilities to store and retrieve data, and the ever-increasing amount of data, is a new thinking required to base solutions on? I would say yes. It is about time to think differently. Yesterday's applications have been very often static and have been just designed to fulfill the current requirements. Performance accessing the data was a limiting factor and prohibited functionality to be built into the solutions. Very often there was a disconnect between domain experts and the ones who implement the requirements afterwards, the IT experts. What we need tomorrow are flexible applications designed to fulfill constantly changing requirements. If you use the right technology and you use the technology to its value, performance should not be the limiting factor anymore. The goal is that domain experts work hand in hand with IT experts. They can use the same tools, understand what data is available, and how the data can be retrieved. How can we get to those solutions? Let me first highlight the evolution using Neo4j. With Neo4j as a graph database, we have been building the graph platform as an entire infrastructure, including graph algorithms to be plugged in to provide functionality, adding ETL functionality and visualization components. Together with third-party tools, you can build what I would call the graph advantage, an ecosystem based on graph technology to be used. If you now combine this ecosystem with the domain know-how, with skill set, with the used professional services packages, partners, SIs, you can build up a graph-based solution as the core and foundation of a new infrastructure. It is worthwhile to describe what is meant when we refer to a solution Neo4j can be integral part of. This is about the Neo4j product, the database, and the Neo4j platform, combined with a data integration platform to access, transform, and load data from all your sources into your environment. A blueprint data model and a blueprint architecture helps to kickstart your project by using already existing components developed and tested with customers and partners who have similar business challenges. Available domain know-how and Neo4j professional services will simplify your journey to build solutions. What you will get then and how will the result look like is basically a Neo4j enabled graph-based solution, which will provide you with agility. The solution will be able to act for constantly changing requirements since the base technology enables agile development approaches, intuitiveness, so that everybody in your organization can understand how the solution is composed and can verify, fine-tune, and give input for additional functionality as needed. And it will also provide high performance to support connected data scenarios, scalability on traversing through connected data, rather than building an ad hoc SQL queries with static data models on static data. Some categories of solutions we have seen and we have worked on with customers are telco, OSS, and BSS, GDPR architectures as foundations for solutions, recommendations, fraud, master data management, and so on, to name just a few. Key features of this graph-based solutions are speed. By traversing through already materialized relationships, you can enable real-time queries. You can provide a 360-degree view on data as you support connections to all kinds of informations to enrich the big picture on customers, systems, employees, etc. You can also use data connections as a value and provide an intuitive solution which supports business needs. A graph-based solutions will be flexible and can adopt additional requirements. Plus, it is resource efficient as a lot less computing power is needed since all the connections are already materialized. So the question then is, what value does this provide for you? You can find patterns within the data, which is something the graph technology really helps. And with that, you can detect anomalies by simply using graph technologies and taking advantage of the capabilities provided by the connected data. You will be enabled to prevent fraud using real-time technology rather than detecting after fraud has happened. With what-if analysis, a customer can see and verify the actions taken. Let's go now a bit more specific into fraud detection and prevention. Just to set the stage, what we can say is that fraud is a significant cost of business, and it's getting increasingly complex. On this market research from 2015, Business Wire estimated the impact of fraud as $16 billion in banking, $32 billion in e-commerce, and $80 billion in insurance. So this is really a big impact on the market. And while this research is from 2015, it's definitely not that in 2018 this has all been solved. It can be more estimated that the numbers went up from there. Who are today's fraudsters? Well, I'm sorry to say, but often they are more sophisticated than most systems one would have to prevent them. The biggest fraudsters don't operate as lone entities today. Instead of an individual, fraudsters are typically organized in groups, also called fraud rings. Instead of using their own identities, they manufacture identities, also called synthetic identities, and they also perpetuate fraud using stolen identities and hijacked devices. Of course, there are many different types of fraud, and all with their own set of complexity. It can be credit card fraud. The merchants themselves can be fraudulent. Fraud rings, where groups of people connect with each other and play a different role committing fraud, are a huge problem and very hard to detect and stop with traditional systems. Insurance fraud is, of course, very widespread, as well as e-commerce fraud. But perhaps the most important fraud is the fraud we don't know yet, because our systems are not capable to detect them. The challenge with fraud, especially from a data perspective, is that it is so many things at the same time. First, it's constantly evolving. It can appear both simple and complex at the same time. Sometimes a scheme involves few or many players. It appears both digitized and in analog forms, and most often fraud is one step ahead. So let's talk briefly about fraud from a data modeling perspective. Because of the complex and varied nature of fraud, all the detection efforts we have in place stores enormous amounts of data. For example, you think about it in terms of storing every transaction being made over a period of time. And finding clear anomalies in one sort of traditional way to go about detecting fraud. A credit card couldn't be in two different locations at the same time, for example. That's a very easy anomaly you can find. But finding patterns supports identifying fraud, simply because typically systems and data are structured in a way to support the regular non-fraud use case, and also simply because luckily the majority of transactions are not fraud. These patterns can occur in many different ways and complexity. However, the job of fraud prevention team is basically to react to patterns by first detecting them, and then second, react and respond. And doing all this is as fast as possible, ideally in real time. The key to achieve this is very much a question of the underlying technology. If you store your data like this, as you would do in a relational database store, you will probably have pretty good success with your discrete analysis, finding the anomalies we talked about earlier. However, if you are looking to detect and respond to patterns, this structure won't be anywhere near sufficient. Instead, what you need to do is reimagine your data in the way it is connected, which of course is a data modeled as a graph. And this is how data is stored and queried in a graph database like Neo4j, and which is the natural expression of your data, where you can intuitively see the data and you can intuitively see the connections within the data. It is obvious that traditional technologies which were aimed at individuals and their behaviors are inadequate to detect and prevent sophisticated fraud rings. With this statement of Gartner, what this statement of Gartner basically translates to is that if you have technologies and system in place to just look at today's fraud case, you will not be able to keep up. You need systems which can be adopted to be flexible enough to allow finding any patterns in the data. Let's look at what traditional fraud detections looks like. Most of the times, the traditional fraud detections are endpoint-centric solutions that analyzes the characteristics of a PC, mobile or telephonic device used to access the enterprise system. They might be navigation or network-centric solutions that analyze the navigation of a session, usually by IP address and user ID, to see if it looks anomalous relative to normal user or peer group behavior. Or they are user or entity-centric solutions in which transactions are compared to what is expected of the user or entity. To support entity prong, this layer also includes integration of external and internal data to help better an identity, especially in a risky transaction, such as in new account applications, or verify a suspect authentication or a high risk transaction. What all these methods are examples of is discrete analysis, which is very effective if you know what to look for. The weaknesses, though, are that discrete analysis do a poor job when you want to detect fraud rings, when someone is using fake IP addresses or somebody has hijacked the device. It also does not help for made up or synthetic identities or for stolen identities. The challenge with systems that focus on discrete analysis for fraud detection is their inability to detect fraud rings. And as this requires additional context and knowledge. Let's take an example. In this simple fraud detection approach, to detect credit card fraud, it is relatively easy to spot outliers. As an example, if you define making credit card transaction around an average amount of past transactions, as long as a new transaction fits this pattern, no further action is taken. But what if the fraudster commits frauds while still exhibiting normal behavior? Well, this is exactly how fraud rings operate. A fraud ring rarely strays outside the normal behavior band. Instead, they operate within normal limits and commit widespread fraud. This is very hard to detect by systems that are looking for outliers or activate activities outside the normal band. Today, financial systems firms need to augment their discrete analysis capability with connected analysis. Whether it is a fraud ring or a stolen synthetic identity, it is powerful to use a graph database. What you then can do is look at your data across channels and across entities, because then you have the knowledge to connect knowledge with each other and to take conclusion out of it. So if you want to avoid fraud to happen, you have a good chance by using the connections within the data, such as for networks of people, detecting fraud rings and finding connections by using, as an example, the shortest path between two entities and analyzing where connections end at, such as more than one incoming connection to a social security number. So the idea might be that you see that a social security number can only be connected to one person, but if you have two outgoing connections in a graph, then you can detect that something is wrong. Or you can detect connections within processes and transactions needed for identifying e-commerce fraud or anti-money laundering, or detecting connections within ownerships. This helps to identify patterns for money laundering, identifying fraud tags and connections between and within legal entities. What you also need is a powerful query language. Cypher is your friend here. With Cypher, you get the ability to traverse within your connections to easily identify and use connections and relationships. Who is using Neo4j to identify fraud? One customer I wanted to highlight is a top-tier payment service. They were basically forced by regulations to put systems in place to identify potential anti-money laundering. Their SQL-based systems were not able to handle the requirements, and therefore they have built up a system based on graphs with Neo4j. As a result, they are able now to group on one side several accounts connected as senders of money, and on the other side the group of receivers. If then, as an example, thousands of transactions are done from a group of people as the senders in, let's say, one city, and they are sending to a group of people in a suspicious country, it is detected and can be further investigated. Can Neo4j also be used to support machine learning? The way I see it, Neo4j can be an enabler technology to support your machine learning algorithms by automated detection of fraud patterns via cipher queries and automated detection of fraud rings, and by verifying if shortest paths are existing. You can also use graph algorithms as the foundation, such as centrality and community. What you can now do is using that the machine learning algorithm will be using all these techniques and all these technologies, and can run patterns detecting algorithms as a background task, and then mark corresponding nodes or derive new relationships, such as customer A is similar to customer B. So that then might be another relationship which helps you to further have your algorithm, your machine learning algorithm, to evolve over time. Furthermore, machine learning algorithms can automatically cancel business transactions, such as a credit card transaction, and also can extend the data model by establishing new connections, which can be then further used. If we now compare using Neo4j with traditional approaches, we see that Neo4j supports finding connections patterns over unlimited amount of hops, whereas traditional approaches are limited, as an example, by SQL join limitations, where naturally complexity would be avoided. Neo4j helps to support the ever-changing needs of fraudsters, changing the way they commit fraud by allowing to connect anything with anything versus SQL needs, to rely on a schema where schema changes to be hard at best. New data systems can be rapidly integrated using Neo4j as the foundation, versus in traditional systems, you need data model changes, need to investigate all queries and the results, etc. With the inherited Neo4j agility, deployment time can be greatly reduced. And as a bottom line, Neo4j helps you to build an easy, fast, and affordable solution. How does Neo4j fit into your environment? If you see existing environments, you most often see relational databases assisting data science teams to support investigations. This is good for discrete analysis, but does not provide a holistic view of data relationships. Query speed is also limited. To integrate the data, this data source are then often pushed into a data lake. This is also good to support MapReduce algorithms, and it is good for analytical workloads. But this still does not provide a holistic view, and it is not good for operational workloads. Typically, you talk here about processes to detect fraud, which takes several days, if not more. But what if then you load the relevant data into Neo4j? With that, you can provide a 360-degree view on the data in real time. With appropriate visualization, you give your data scientists the ability to access the data in real time. Existing transactional systems will be connected in a way that the transaction stream is loaded to get sense out of transactions in conjunction with the existing connected data, and you can respond in real time with alerts and notifications. The resulting graph data set can be then used to explore new insights and find and detect patterns. Let's look into an example for fraud solution architecture. In this example architecture with the building blocks, you build a fraud solution based on Neo4j. In the center of this architecture, you see the Neo4j database as a cluster. The green components are components from the Neo4j platform coming with the Enterprise Edition. Fraud detection algorithms developed jointly together with the domain know-how of the customer can work automatically directly on the database to detect fraud patterns and derive new connections. Applications on top designed for fraud analysts or managers with dashboards could access the database via the boat driver, making it easy to leverage the value of the Neo4j graph database cluster functionality and scaling the workload. The Neo4j database is directly connected in batch or real-time with all other source databases to import the relevant data initially and feed detections from fraud investigations into other systems and simply load the delta from new inserted data. With that as an example, a CRM system can get relevant information so that, as an example, in a CRM system, a suspicious pattern customer is marked or a transaction such as a credit card transaction can be cancelled. So if we summarize the characteristics of a Neo4j powered fraud solutions, we can conclude that this adds value by providing agility. You can constantly catch up with fraudster activities and you are enabled for future requirements. Intuitiveness, fraud analysts are enabled to use the technology and can use visualization techniques to detect patterns. Speed, traverses are cheap and provide performance so that you can detect complex connections. You can leverage data connections to get a 360-degree view on customers. Hardware is efficiently used with real-time patterns, and your investment in other systems is protected with rapid return of your investment by using agile approaches. As a conclusion, beside graphs being everywhere, using graphs as a foundation for your solution adds significant value. Who can help? Our Neo4j professional services, as well as our certified partners, can help to go this journey with you. Beside the database expertise in Neo4j, our team has significant know-how building solutions to speed up your implementation cycle. We can provide best practices and building blocks of architectures and other know-how to be used. With that, I would like to thank you for your attendance today and would also like to hand back to Angelica and open for questions and answers. Thank you.